last science fair, we made a motorized skateboard. The thing that inspired me to make the motorized skateboard was me and my partner Gabe's constant love for skating since we were younger. And we've always been interested in electric skateboards, but we could never find one that was affordable in less than around $500. So the board has a power button with the battery icon stored right there to show the power. You turn it on, and the parts on the top of the board, you have the control board, which allows the remote to control the motor. And connected to that are the two 18.5 volt lithium polymer batteries, which power the board. And then,
Go. Hi, my name is Joe Kawazinski, and I'd like to talk to you about the battery portion of our project. The battery we chose was a LiPo battery. It's lighter, therefore making it easier to move, like if we need to take it off and adjust something. It has better housing, thus meaning it doesn't take up as much space on the board. But the negative to it is that it can lose power if we don't charge it correctly or even possibly light on fire. The second battery choice was a nickel metal battery. Its power is a lot stronger than a LiPo battery, but it's not practical. Its power capability is good, but then again, not practical. Its cons are its life isn't as long as a LiPo battery. It can lose battery life just by itself by sitting there, and that happens really fast. And the third battery is a lead acid battery. It's powerful, it's easy to charge, high power capability, but it's big, it's heavy, and it's just too much for the board. Then with the LiPo batteries, we put them in a series, which basically means that it adds the two powers of the batteries together.
if forces are balanced, you will simultaneously move forward with the board, allowing a smooth mode of transportation. If you accelerate too fast, the board will feel like a banana peel going underneath you, falling, making you fall, and you kick the board forward and you slide back.
3, 2, 1, go.
We decided to put the LiPo batteries in a series, meaning that it adds the two powers of the batteries together. So the volts were 18.5, thus making it a 37 volt power. Though it keeps the same battery life, it's just a better, more powerful way to use the batteries. We could have put it in a parallel circuit, but it just would make it have a longer battery life, but not as much power. And it just takes
2, 1.
These circuits share many similarities, like they distribute power to the system equally. The batteries can be recharged separately, like taken out of the circuit and put back into it. And also, different batteries can be put into it, like if we were to use the lead or the LiPo ones, which we did.
Another consideration with the motor was the acceleration. The acceleration at the start was a little bit powerful, but it takes some getting used to, and you'll be fine. Because the original top speed is quite fast, but it'll eventually slow down, and then you'll be able to control the speed.
Of our project. So the battery we chose to use in our project was the LiPo battery. It's lighter, thus meaning it doesn't need as much energy to push it. It has better housing, therefore meaning it doesn't take up as much space on the board.
One of the problems was the amount of torque at the start of the motor. Torque is the force used when twisting an object, and the wheel has a pretty strong start, so there's quite a bit of torque, which takes getting used to. There we go. The first questions for the board was electric charged motors or gasoline powered motors. And we ended up going with electric because it has less carbon emission, which is better for the atmosphere. And because electric is much easier to charge, that you can do it from an outlet. To charge the lithium polymer batteries, we had to use a LiPo balance charger, which is required to charge lithium polymer batteries, because if not done correctly, they could catch fire. And on the bottom of the board, we have a brushless DC motor connected to a sprocket, which is attached to the belt, which is connected to the sprocket bolted into the bottom back wheel, allowing it to move forward. So, to turn it on, you have your controller on. it allows the board to move forward. With, I don't know, different acceleration levels, right?